Graphs might sound complex, but today we'll break them down super simply. What are graphs? How do we explore them using BFS and DFS? By the end of this video, you'll see how they work. A graph is just a collection of nodes called vertices and connections called edges. You can think of it like a map. Here we have sites and roads, that is, nodes and edges. Graphs can be undirected and directed. They can also have weights like distance or cost, but today we'll focus on basic traversal. Let's start with BFS, and it stands for Breadth First Search. BFS explores a graph level by level, like ripples spreading out in water. So let's take an example here. Here in this graph, we'll start searching from 0. We'll consider this as our root node. So the first step is select a node. We selected 0 here. Then you need to visit all its neighbor. So the neighbors to 0 are 4, 2, 3, and 1. These are direct neighbors. So here we count 2, 4, 1, and 3 as neighbors. And then visit their neighbors. So here only 5 is left, so that is second neighbor, and so on. It uses cues like people lining up first in, first out. And the use cases include finding the shortest path, social network friend suggestions, and crawling the web. Now let's look at DFS, depth first search. DFS goes as deep as possible before backtracking, like exploring one hallway before fully trying another. It uses a stack and it uses last in first out, or with recursion, the call stack does the work. So let's take an example again. So here we start with 0 as our primary node. From 0, we have two options. Either we can go to 2 or 1. For example, let's go from 0 to 1. So we need to explore all the possibilities and you need to track all the nodes you visit. So from 1, you can either go to 4, 3, or 2. So let's say we go to the node 2. So after reaching node 2, there are no more possibilities. Either you can go back to 0 or 1, but we have already explored those. So what we'll do is from 2, we'll go back to 1. And from 1, we have two possibilities again, that is 4 or 3. Let's consider we go to the node 3. From 3, we have possibilities of going to 5. So for example, we go to 5, then we have two choices again, that is 6, 7, sorry, there are three choices from 5, that is 6, 7, and 8. So let's say we go to node 6, and from node 6 there's another dead end, so we go back to 5, and then from here we have two choices, either it's 8 or 7. So let's say we go to node 7, and from 7 we have possibilities of going to 5 again, but we won't do that. We'll directly go to 8, and from 8 we have two possibilities. First is 5 that we won't choose, and then we need to go to 9. So here, after reaching 9, there's a dead end again. So after analyzing everything, you need to see what nodes are left. So from 9, you'll go to 8. From 8, you can go back to 7, then back to 5, then back to 3, and then back to 1. From 1, you need to see which option is left out. So we explored 3, the only option left was 4. So you go to 4, and then we'll do the last step of backtracking. That is from 4, we'll go to 1, and then ultimately we'll go to the node 0. So that is start with a node, go deeper into one neighbor, then deeper, and backtrack when stuck. Use cases include maze solving, topological sorting, and cycle detection in graphs. Imagine a maze. BFS explores every room level by level Slowly but surely, DFS runs into one hallway and keeps going until it hits dead end. Then, if you're trying to find the shortest path, go for BFS, and if you're trying to explore everything, use DFS. To recap, graphs connect data like maps, BFS goes wide and uses queue. DFS goes deeper and uses stacks or recursion. So which one clicks you? DFS or BFS? Let me know if you want full coding walkthrough next. Like, subscribe and keep learning.